This document explains how and when an interface may be used while coding in Java. There can be other uses of interface, but this video does not explain there are other forms of use for the usage of the interface class. Let's first start with an abstract class, and then we explain how an abstract class and an interface may be used for different purposes. An abstract class represents a class that cannot be instantiated due to one or more methods being defined abstract. For example, we may have an animal class with methods setName, cry, and eat. Among these methods, setName can be defined because it may set the name of an animal. However, we may not be able to define the cry and eat methods because the crying behavior and the eating behavior depends on the type of animal. Thus, we may define the animal class as an abstract class as is shown in this particular slide. In this slide, observe that the cry and eat methods contain the abstract keyword to signify that they are not defined yet. Also observe that we have made cry and eat public to signify that these methods are accessible by any other class. However, we may also make them protected if we wanted only the derived classes to use them and not by other classes. Hence, the use of public or protected is not restricted while using an abstract class. If you are interested in modeling specific animal types such as humans, dogs, or roosters, each of which have the specific cry and eat behavior, we may define the code as follows. Thus, we have a human class which extends the animal class, but in this class, the cry and the eat behavior have been defined. Hence, this class, human class, is not abstract. Similarly, we have the dog class with the cry and eat behavior defined, and the dog class extends the animal class. And we also have a rooster class which extends the animal class and in which the cry and the eat method have been defined. You have to remember the usage of the keyword extends in each of the classes to signify that the subclass human is a type of animal, and that subclass dog is a type of animal, and that subclass rooster is a type of animal too. Also observe that the eat and the cry methods have the unique definition in each of the subclasses. The corresponding class diagram, UML class diagram for the above code is shown now. Observe how we have italicized the cry and the eat method to indicate that they are abstract. That's the UML form of specifying abstract methods. Also we have added the stereotype abstract to specifically say that animal is of type abstract. Also, human, dog, and roosters, since they extend from animal, so is in UML this is shown using the is a relationship, and the is a relationship is a arrow with a triangular head. Now we can illustrate the polymorphic behavior. Observe that the data type in this code, observe that the data type of all animals is an array of animal, whereas the right hand sides are instances of humans or dogs or roosters. This is acceptable because of the is a relationship that we used in the form of the extends keyword. That is, a human is a type of animal, a dog is a type of animal, and a rooster is a type of animal. At runtime, the appropriate types of objects are invoked, illustrating polymorphic behavior. Hence, we do not need to specifically write a statement such as, if the type of object is of type human, then invoke the cry or eat method, of the human class. So that is avoided. At runtime, the Java virtual machine realizes what kind of objects are actually what kind of object each animal refers to, and then it will invoke the appropriate method that is invoked by the animal reference. On observing the class diagram and the Java code, it now becomes apparent that the superclass animal may have a number of methods, some of which are public and some are private or protected. Hence it is not readily evident what methods in the class, such as human or dog or rooster, are public interfaces to other classes. In other words, application programmers may not readily know what are the available methods for public use when they want to use the classes in, or when they want to extend their code or for evaluation purpose. One way to do this is to specify the set of public methods in an interface class. So we may define an interface containing the abstract method cry and eat as follows. Observe the use of the keyword interface in Java. Also observe we do not use the keyword class when we use the interface. Now our animal class may be defined to simply contain those methods which are not publicly accessible except for the constructor. Hence the animal class may now be coded as is shown in this block. Note that the animal class is not abstract anymore in our example, because the behavior of cry and eat will be specified in the subclasses of animals, and these subclasses will also implement the animal API's interface. However, the animal class may also be defined as abstract if there are other abstract methods which are non-public, but in our examples we do not have any abstract methods, hence this class is not an abstract class. Now each of the subclasses can be coded as follows. For example, the human class may be coded as follows. Observe we use the class human extends animal to specify that human is a type of animal, plus we also use the keyword implements to specify that it uses the animal API's interface. The rest of the code contains the definition of the constructor and the implementation of the cry method and the implementation of the eat method. So we clearly see that the human class uses is a relationship from the animals and from the animal API's classes, that is, it follows multiple inheritance. So this is the way by which multiple inheritance is followed in Java. Java does not use direct multiple inheritances, but when using interfaces, then we say we can implement multiple inheritances in Java. Similarly, the dog class the definition of the dog class is now shown now, and it's exactly similar to the human class. And the rooster class also uses similar code to the dog class and the human class. The UML class diagram of the code, this time using the animal class and the animal API's interface, is now shown. So we now see that human class extends from animal, as well as the human class implements the animal APIs. This is the notation. The dot notation is used to specify implementation of an interface in Java in a UML. So we still use the same arrow with the triangular arrows, but in the case of interfaces we show it with dotted lines. From the above code and the class diagram, it becomes apparent to the application programmers that the public APIs of the human class, dog class, and the rooster class should follow the signatures of the methods in the animal APIs. So the public methods of these are defined, the public methods of human, dog, and are actually defined, that are common to the three are defined in the interface class. So an application programmer finds it much easy to invoke the public methods, first of all to know what public methods are available and to invoke them while extending his or maintaining his code. And this is a much simpler implementation to maintain than the previous code that I had explained earlier. Finally, we may use polymorphism in the following way in this case. In this case, a human is a type of animal as well as a type of animal APIs. That is, we may have multiple inheritance through the use of interfaces. Similarly, a dog as well as a rooster is a type of animal as well as a type of animal APIs. Since the cry and eat methods signatures are now specified in the animal APIs interface, and since we want to invoke the polymorphic behavior of the cry and eat methods, we now specify that all animals is of type animal APIs rather than of type animal in this code. So that will make it easier for us to invoke the cry and eat method at runtime, and the appropriate type of objects would then be invoked.